And again, welcome to today's webinar, Scaling Up Tenfold with Amazon EC2 Spot Instances. Our presenter today is Chad Schmutzer. Chad is a specialist solutions architect with Amazon EC2 Spot Instances. Today with us, we're also excited to have Boyd and Sebastian, who will be our Q&A moderators throughout the presentation today. So submit any questions you have. They've been doing their hand stretches, getting ready to type away furiously to all of the questions. Chad, welcome. The floor is now yours. Go ahead and unmute your microphone and begin.
Thank you, everyone. My name is Chad Schmutzer. I'm a solutions architect focusing on EC2 Spot instances. So today we're going to learn a bit about Spot instances, see some customer examples, and then dive into some demos. Hopefully we have time for some demos, and then we'll do some Q&A at the end. So a bit of overview of what we'll cover again. Finally, at the end of this, we will save a few minutes for some questions. So please do submit your questions to the moderators. I'd love to answer a few live, and also have the moderators ask as many answer as many as they can live. So again, thanks. We'll go ahead and get started here. All right, so let's cover briefly an overview of the 3 different consumption models when it comes to spinning up EC2 instances. Right. So the first, I think we're all familiar with, which are on demand. The ability to simply spin up instances and pay as you go, sort of just like your lights, the utility model, right, where you pay for the electricity that you're using, and when you shut the lights off, you stop paying for it. The second would be reserved instances, right? This is the ability to purchase capacity in our data centers for a 1-year or a 3-year period of time. In exchange, we give you a discount for helping us estimate our future capacity. And these are great purchasing models for workloads that are steady state and that you can predict for a given period of time. So the third focus that we'll spend today, which is understanding the spot market, that's really the third method for procuring spot EC2 instances. And so what this is the ability to bid for excess unused capacity that we currently have in our EC2 infrastructure. So let's dive into this a bit, right? So we have a lot of customers running workloads on AWS, millions of active customers every month. So what does this mean? We need to have a lot of extra capacity sitting around in our data centers to allow our customers to spin up workloads on the fly, on demand, scale up, scale down, whatever our customers need, we need to give them the ability to spin up their resources. And so that means we have a lot of spare capacity sitting around, right? So rather than letting that idle spare capacity go unused, we've essentially opened that up into a service that we call EC2 Spot Instances, also known as the spot market. And so spot instances are essentially spare EC2 capacity with a couple of very simple rules. So my slide is taking a second to catch up here. All right, I guess this one's not showing. So I've got a slide here that's demonstrating a couple of 2 simple rules that come to spot instances. So the first would be that spot instances are based on a real-time market that is based on supply and demand, right? So as customers are spinning up instances, that affects the current market price, and also as capacity comes and goes, that also feeds into the market price. The second is that you never pay more than what you bid, and ultimately you never pay more than what the current market price is for a running instance, right? So that gives some room between what you bid and what the current market price is. If the market price ever exceeds your bid, you get 2 minutes to wrap up your work. You get a warning, you get 2 minutes to wrap up your work, and then move on. So what does that mean, right? At the end of the day, spot instances really provide the best value for your EC2 capacity, right? So since spot instances typically cost 50 to 90% less than on demand, you could approach this, applying this to your workload in a couple of ways. The first is if you're in the need for extra capacity, if you're in a position where you said, I'm running, but I really wish I could spin up more instances or have more compute capacity for my particular workload, then by all means you could increase your existing capacity by moving to Spot instances without changing your budget, right? Or if you're in the mode where you'd like to reduce your current spend on your existing workload, moving over to Spot instances is also a great option where you could immediately start to save, somewhere between 50 and 90% on average on your existing workload. So in my humble opinion, these are both great options, and in either way, I think you should give it a shot. That's my little graphic there of sliced bread, which I like to say Spot instances are the greatest thing since sliced bread. Hopefully somebody's laughing at that silly joke there. All right, so understanding EC2 capacity, right? So this is crucial in understanding how to use Spot instances and the spot market, right? So let's take one of our regions, Northern California, for example. Every region that AWS offers has at least 2 different availability zones, right? So these are separate and physical data centers. And so clearly these are separate pools of physical hardware capacity, right? So if we then look at our instance types, so on the screen I have, for example, P2s, C4s, M4s, I2s, these are all running on separate underlying physical hardware, right? Because there can be differences in the underlying hardware models that are powering these instances. So therefore that requires them to be living on separate physical capacity, right? So if we then take it a step further, if we start to look at each of the individual instance sizes within a family, so the large is extra large, is 4 extra large, 8 extra large, again, these are all separate physical pools of hardware capacity. And then if we slice it horizontally here across shared and dedicated, when you spin up an EC2 instance, you can specify the tenancy model, whether it's running on shared infrastructure or dedicated infrastructure. So again, these are all separate pools of hardware capacity. So what does that mean when it comes to Spot instances? That means that every single one of these rectangles you see here are a separate spot market because they are separate pools of hardware and physical capacity. So speaking of dedicated instances and dedicated tenancy, I did want to point out that as of January 19th this year, we did enable the ability to spin up dedicated Spot instances, right? Same pricing as shared tenancy, so a pretty big win there in terms of running if you have requirements for running on dedicated instances, please do consider using the spot market for those. So quick recap here of capacity and spot markets and how this all fits together, right? So let's take the C4 instance type as an example, and let's look at a region that has 3 availability zones across the top there, 2A, 2B, and 2C. So we see that each of the instance sizes, right, within the C4 family, as well as each of the AZs have separate pricing for the spot market. So this is an example of a snapshot in time of pricing, I think from last year sometime. And you can see there that the on-demand price for each of these instances is listed there on the right-hand column. And so you can see that the prices do fluctuate between availability zones as well as between instance sizes. And it's important to understand, right, that, again, every family, every size, every availability zone in every single region, right, this entire rectangle itself is a region, is a separate and unique spot market. And prices in one AZ do not affect prices in another AZ. So let's take a moment to understand a bid price for a spot instance request versus the market price, right? So here is a snapshot of spot pricing history for a particular instance. This is the R3 4 extra large that was running in US East 1D. This is a week's period of time. You can see the current market price is just under 18 cents per hour, right? So had we bid 25% of the on-demand price, right? So that's that black line there. you can see that we would have experienced roughly 4 interruptions over that week's period of time. And an interruption is defined as the spot market price exceeding the bid price, the instance receiving the reclaim notice, and in this case, we would have received roughly 4 of those. Still would have saved roughly 86% off of the on-demand price over this week's period of time. So had we bid 50% of the on-demand price, you can see again, we would have only experienced 1 interruption, and because you never pay more than that green line, right, you would have saved 85% versus the 86% off of the on-demand price, and you still would have experienced only 1 interruption over that week's period of time. So let's take it all the way up to 75%. If we had bid 75% of the on-demand price in this week, we would have had 0 interruptions. This instance would have continued to run uninterrupted for the entire week's time, and our savings would have been exactly the same as the 50% bid point, right? We would have still have achieved 85% savings because, again, even though we bid 75%, we only ever pay what that green line requires, which is the current market price. All right, so let's talk about some best practices when it comes to running spot instances in particular. And you will see that there's a lot of overlap with general best practices for running EC2 instances, right? So making sure that your applications and your environment is stateless, right? So what does that mean? That means the applications that are running on an individual EC2 instance don't contain the state of the running environment, right? That state is kept somewhere else, whether it's kept in DynamoDB or Elasticache or RDS or a database somewhere. The instances themselves, the jobs and the applications running on the instances don't contain the state. So that allows us to treat the underlying instances and applications running on them as ephemeral, right? They can come and go as needed to power our environment. Second is fault tolerance, right? We want to make sure that at every point in our application, we have redundant components, we have the ability to fail over, whether that means failing over within an internal application or failing over a database or across an AZ. All of that needs to be considered and built into our applications. The third would be multi-AZ, and this ties back into fault tolerance quite nicely. You know, you have the ability to deploy multiple EC2 instances across 2 or more physical data centers, being the availability zones. So by all means, if your application needs to be redundant and highly available, then take advantage of the fact that you can simply deploy your instances across multiple physical data centers or AZs. The fourth is making sure that your applications are loosely coupled, right? So you don't pack all of your eggs in a single basket. You don't put all of your application tiers in a single instance. You spread them around. That allows you to, increase capacity for only the components that need it in your application. If you packed on the web server, the database server, the caching server all in the same instance, and it turned out that you needed more memory for the database server, well, you've got to increase the memory for everything, not just the database server, because everything is running in the same place. So keeping things loosely coupled really allows you to make sure that your application and your environment are tuned for your exact workload. So the fifth best practice, it really comes down to instance flexibility. And so this is what makes spot instances unique. So, checking out your workload and your application and understanding, can I run my application on different instance types and possibly even sizes, right? So we want to check. In often cases, applications can run just fine on instances that have similar compute capacity or perhaps even more compute capacity, so more memory or more CPU, for example. And even if your application can't take advantage of it, let's say it's not multi-threaded or it's not designed to run on more than 4 virtual CPUs or whatever, more oftentimes than not, it doesn't really hurt to have that extra capacity. So if you were running on 4 extra larges and then you were able to get an 8 extra large on the spot market for the same price or less, then by all means consider using it because it doesn't hurt you to have that extra capacity. So what does this look like, sort of maybe from a 3-tiered web app kind of environment, right? You have maybe a load balancer, and behind that load balancer you have picked similar instances with similar performance characteristics, maybe a C3 large, an M3 large, M4 large, R3 large, C4 large, right? These are all going to give you more or less similar performance characteristics when it comes to serving your data behind a load balancer. And so this is one possible option that you could use when it comes to using the spot market to power your web applications. All right, so I hear often that customers have workloads that just cannot be interrupted, right? So I like to show this study that Cloud Health did across all running EC2 instances, and it turned out that, well, 21% of instances run less than an hour, 35% run less than 2 hours, on and on, 40% less than 3, all the way up to roughly 50% of all EC2 instances live less than 6 hours. And so what does that mean? If you have instances that fit into this category and you would still like to use the spot market, we have something for you, right? We have a service and a feature called EC2 Spot Blocks. So spot blocks are the ability to request that your spot instances are running for a defined duration, right? And this duration can be anywhere between 1 hour and 6 hours. And this is just another parameter that you pass when you put in your spot instance request. So a spot block, again, can run anywhere from 1 to 6 hours. Savings are roughly 50% off of the on-demand pricing. And again, it's just a simple additional parameter for you to pass to your spot instance requests when you're making those requests. Let's jump into a couple of example customer use cases here. The first one is near and dear to my heart. I've worked closely with this group here at Caltech. This is the Guttman Lab, who is doing genomic sequencing on top of AWS, and in particular has been able to utilize spot instances for this particular workload. So the IT staff that is supporting this particular professor has really changed the way that he's able to get his research done. So he's not in a position where he has to go out and purchase hardware and maintain physical capacity somewhere, in a closet somewhere on campus. And instead, he's able to run his workloads in the cloud, scale them up and scale them down based on real-time needs for jobs, and is able to get quite a bit more work done. In this particular case, quickly computing across 1,000 or more nodes for their genomic sequencing workloads. Second customer example is Yelp. So Yelp gave a great talk at the most recent reInvent back here in November of 2016. Yelp has built an internal system called Seagull, which is their own internal distributed system for concurrent task execution. So they basically built out this Seagull system and were able to migrate it to spot instances over a period of time, just under a year here. And you can see the timeline here at the bottom. They gave a great graph showing savings as they moved into the spot market, right? So that first pretty significant drop in price, that 55% reduction in costs, was after their initial transaction to spot instances. That is just simply going from on-demand to spot. That second significant drop, where they achieved an additional 60% savings, was really after they got in and fine-tuned their workloads for spot. They enabled auto-scaling with Spot Fleet. They were really able to dial it in and really get the ultimate savings while achieving still great amounts of compute capacity for their concurrent task execution. So great use case there. So let's continue on through a service called EC2 Spot Fleet. And so what I'll do is I'll dive into what Spot Fleet does here and what it offers you. So Spot Fleet is really the ability to launch a single or thousands of spot instances with one single API call, right? The request Spot Fleet API call, right? AWS is built on top of APIs, and so we've exposed the Spot Fleet service through an API, and we've made it so that you can think less about bidding and strategies and focus more on your applications and your workloads, and just focus on understanding what you need and letting Spot Fleet go out and maintain procure and maintain that capacity for you, right? So you can choose two different allocation methods when you spin up a spot fleet request, right? The first is to say, you know what, just go out and find me the cheapest price at, that you can possibly find for the horsepower that I need. So rather than trying to have spot fleet distribute across availability zones or different instance types, you can say, spot fleet, just go find me the cheapest instances that are available in any AZ. I don't care. I just want to get a bunch of work done. I just need some compute capacity, and I want to pay the minimum price. The second would be the ability to request diversified workloads, right? So in the diversified allocation strategy, spot fleet will do its best to diversify your spot instances that it spins up across as many different instance types as you've supplied it with and as many different availability zones as you've allowed it to use, and then still balancing cost in that mix, right? So it's a combination of instance types, availability zones, as well as price. Lastly, you can do what is called custom weighting when you request a spot fleet. And so this is important to understand, because if you are asking for a diversified fleet request where you have instances that may be scaling horizontally as well as vertically, it may be the case that that spot fleet spins up an 8 extra large and a 4 extra large. Well, in that case, if your workload is dependent on capacity or sensitive to amounts of horsepower for each of the instances, you can apply weight. So you can say, spot fleet, you can either spin up 1 8 extra large or 2 4 extra larges, and then spot fleet understands that 2 4 extra larges is in equal capacity to an 8 extra large in your particular scenario, and you can define these custom weights. Right, so we do want to make sure that customers are aware that we're adding features to spot fleet as quickly as we can. My slide is not coming through here, that's showing the significant features that have been added over time. However, what we've done is we've added the ability most recently to enable auto-scaling within a spot fleet request, right? So that means you can have CloudWatch custom and familiar CloudWatch metrics and alarms powering your auto-scale for a spot fleet, and have your auto-scale, have your spot fleet scale up and scale down in real time based on metrics that you've provided it to be scaled on. I mentioned earlier the ability to run spot dedicated instances, and most recently the ability to enable health checks within your spot fleet, so that spot fleet can detect if you terminate an instance. So if you manually removed an instance from your spot fleet, or if one became unhealthy due to not passing an EC2 health check, spot fleet will detect that and replace it for you as well. So let me move on to my next slide here. All right, so the Spot Console is the console within the dashboard for the EC2 Spot service within the AWS console. This is the location that you can easily spin up Spot instances through a nice web GUI. There's a lot of powerful features, but still it's kept simple enough that you can quickly figure out what you need to launch and do that in a very quick period of time. So you may be thinking, it sounds like there's things to understand when it comes to understanding bidding strategies. Which availability zone should I look at? Which instance types? So we have a tool for that as well, right? It's called the EC2 Spot Bid Advisor. It's available on our public website within the Spot documentation. There'll be a link for it at the end here. But what it lets you do is it lets you plug in some values. And in this case, we're saying we need instances that have at least 4 virtual CPUs, instances that have at least 7 gigs of memory, and I'm willing to bid 50% of the on-demand price. And so the Spot Bid Advisor will then spit out a list of results based on real historic pricing, and just show you, had you bid this strategy over the last month and week, right? Your M4 extra large, which meets your capacity requirements, would have had experienced 0 interruptions. So low in this case means 0 interruptions over that period of time. So your instance would have run for an entire month without an interruption, and over that month's period of time, you would have achieved 91% of savings over the on-demand price. So, that's fantastic. Same EC2 capacity, same instance that was running for an entire month uninterrupted, and you saved 91% off of the list price, essentially, right? And so this tool is for you to use and to help you understand, historic pricing, as well as what, where you should target your workloads. We also do publish historic spot pricing through an API up to 3 months in time. So if you wanted to query that, it's all available in the API, in the console. There are graphs. By all means, check out pricing history and understand what it means for you. All right, continue here. For those of you that like to use the SDK or the CLI or command line, we have a code repository on GitHub called the EC2 Spot Labs, where we publish quick little tools for you to use for your own environment. In this case, I'm showing a tool called getSpotDuration.py. It's a Python script that essentially does what the Spot Bid Advisor in the console does for you, but from the command line, right? So you can take this Python code, you can modify it to fit your needs if you need to, or use it as is. It's completely open sourced, but you may be submitting bids from the console, from the command line, and maybe you're feeding those the Spot instance requests from this Python script, for example, right? So a lot of flexibility there is really what I'm trying to say. The most recent thing that we released in the console itself would be the Spot Advisor. The Spot Advisor is another button within the EC2 console dashboard that lets you say, I have a workload, whether it's a web service or a MapReduce job, Hadoop, or a batch job, and these are the compute specification minimum requirements that I'll need for it. Please go out and recommend a fleet based on historic pricing, my requirements, and the type of workload that I'm after. And it will simply spit out some results for you here. It will give you a nice list of instance types that it thinks you should use, what kind of capacity they have, the interruption likelihood, and then the estimated price per hour if you said go ahead and run this fleet. And so in this case, it would take into account 30 different instance pools, and it would achieve an estimated 83% savings off of the on-demand price during the life of your fleet request. So in addition to the tools that I've just showed you, we also have some great partners out there that enable customers to utilize the spot market. Spot Instance, one of them. They provide some conclusion board within their own console that gives you some neat pricing metrics and historic pricing. Qubel as well for big data workloads. They're a great partner that enable customers to do big data analysis on top of Spot instances. And then HashiCorp Terraform that I wanted to give a call out. I know that there are a lot of users of Terraform, and Terraform does have native support for Spot instances and Spot Fleet. So if you are a Terraform fan, by all means use it to spin up and procure your Spot instances. So I did mention earlier that when a Spot instance is going to be reclaimed by AWS, it receives a 2-minute warning. And that 2-minute notification appears in instance metadata. So that gives you a full 2 minutes to wrap up your work, do whatever you need to do on the instance before it is reclaimed. 2 minutes is quite a long time for you to go ahead and copy data, maybe from the instance to S3, maybe snapshot what you've been working on or checkpoint your application. Maybe you need to put the instance into connection draining mode and then detach it from a load balancer, right? Lots of different options. And so, here's a sample script that you could run on the instance, right? This script could simply be a while loop that says, do I see the termination warning? If it's there, take this action, right? Detach myself from my load balancer, put myself in connection draining state, and move on. If that warning does not exist, then go to sleep for 5 seconds and try again. So this will just continue to loop all the way until a potential termination warning is provided to the instance. All right, so let's just take a quick look at some different architectures for running your Spot fleet with auto scaling. Right, the first is batch processing. Right, we have 4 different potential batch workloads here. There are many others than this. These are workloads that we see happening and running often on top of the spot market. Right, Monte Carlo simulations, molecular modeling, media processing, and high energy simulations. These are all fantastic options for doing batch processing type workloads to still achieve 90% savings off of on-demand cost. Unfortunately, this slide animation is not showing as well, so I'm going to power through it. So here's an architecture for queue-based processing. This is sort of a typical pattern here where we have the region itself, we have multiple availability zones being utilized. Here in this case, we have 3. We have spot instances running in all 3 availability zones, and we have a 4th instance running in a 4th AZ called a cluster controller. And this cluster controller, for example, may be distributing work across your spot instances that are running across all of the availability zones. Perhaps you're checking out work from an Amazon SQS queue, saving state of your work in DynamoDB, and then maybe ultimately storing the results in Amazon S3. And so this is just a nice architecture that sort of shows how everything fits together. So we did some sample metric collection for batch processing workloads. In this case, we requested 1,000 virtual CPUs over a 30-day period of time, and we graphed the results, right? So in this case, the minimum number of virtual CPUs that we had running at any given time was 960, right? So that's not much less than 1,000 that we asked for. The actual mode turned out to be 1024, and the average was 1012, 1,012 virtual CPUs. And again, over this 30-day period of time, the average price of the virtual CPUs turned out to be just under 1 penny per hour, right? 1.2 cents per hour. And that results in a savings of over 80% over that 30-day period of time. So second use case is live and video on-demand streaming content. So in this case, what I'm demonstrating here is we have a source encoder. In this case, this is a 360-degree camera. So I don't know if you've been seeing these new videos that are popping up on Facebook and YouTube where you can kind of twirl around and see the entire field of view. This is an architecture that we've built out that captures live streams from a 360-degree camera, encodes them in real time on our origin servers that are running on spot instances, and then distributes and serves out that real-time stream through an application load balancer, and ultimately through CloudFront. So you can have your viewers viewing real-time 360-degree streaming camera through this entire architecture that is running completely on Spot Fleet. On the lower part of this architecture, we can see that we're also, at the same time that we're streaming the live stream, we're also saving it to S3. And then what happens is we have a worker queue, this batch process down here in the bottom, that is saying monitoring number of videos that are in S3 via an SQS queue. And for every new video that comes in, the Spot Fleet fires up and starts transcoding those videos into different formats and different frame rates, so that those videos can then be consumed in a video on demand format, right? So think about Netflix streaming a movie on your phone or on your iPad or on your Fire TV, right? So lots of different methods you would be streaming that video on demand. And so Spot Fleet is taking care of transcoding that single live stream into multiple streams that are fitted for the formats for the various end users that may be viewing that media. So let's talk about running a stateless web application on Spot Fleet, right? It's really no different than if you were using traditional auto-scale groups with on-demand instances or reserved instances, right? In this case, we've simply swapped out our auto-scale group for a Spot Fleet with auto-scaling enabled. We're still keeping our session state in another place, such as Dynamo or Elasticache, here represented by that blue bubble there on the right. But again, same concept here. We've got a load balancer powering our application running on Spot instances. Since Spot instances are typically so much cheaper than on-demand, it's very easy to simply over-provision your instances if you are concerned about some fluctuation, some churn at the instance level. But again, if you've over-provisioned by 20%, and you refer back to that graph that I showed with the batch processing history where, the average number of CPUs over that given period of time remained flat. You can consider using Spot instances for your production type workloads for web applications as well. And so we also have a graph that shows, in this case, we asked for 50 instances over a 30-day period of time. Over that 30-day period of time, we never dropped below 45 instances. During that period of time, if you had wanted the entire 50 instances and could withstand dropping to 85, you would have achieved 85% savings off of on-demand. And if you really only wanted the 45 to begin with, your discount would have been 83%. So, again, thinking about, fluctuating from 45 to 50 or above, is plenty of capacity to power a typical web application. So the last scenario I'll talk about here is what I think is a great fit, which is running your containers on Spot instances or Spot Fleet. So in this case, what I'm demonstrating is running your ECS cluster, right, the EC2 container service, your cluster of EC2 instances on Spot Fleet, and then allowing the ECS service to deploy your containers on top of your ECS cluster onto Spot instances. So why do I think this is a great fit, right? There are a couple of reasons. The first is that, Spot Fleet thrives on diversity, right? So there's a case where I may be having different instance types, different sizes with different amounts of horsepower. With containers, I'm asking for a set of resources. So when I deploy a container, I'm saying I need X amount of CPU, Y amount of memory, now go find a place for it. So in this case, ECS is going to do a really good job of making sure that it squeezes every single resource out of all of your EC2 instances as best it can, because it's going to simply treat your underlying capacity as a pool of resources. So you can do things like smart bin packing. You can do things like diversify my containers across multiple instances, across multiple AZs, which ties really nicely back to that allocation strategy of diversified when it comes to running your Spot Fleet. Go. Hopefully my screen is coming through. Can everybody see my web browser? All right. So what I've done here is I have launched a Jenkins web server running on Spot instances, and so I wanted to demonstrate what this looks like. This Jenkins server, let me pull up the CloudFormation template here for you real quick. Sorry, I should have had this open already. All right, so this is a CloudFormation template, and again, hopefully this is coming through in my browser okay. This CloudFormation template launches a Spot Fleet, and then it also deploys an application load balancer, and finally an ECS cluster, running an ECS service on top of my Spot Fleet, right? And it also enables auto scaling within my Spot Fleet so that I can actually allow Jenkins, right? Jenkins, which is running as a container on top of my ECS cluster, which is on top of Spot Fleet, I allow Jenkins to scale up and scale down worker nodes in my Jenkins cluster based on number of jobs in my Jenkins queue, right? So this particular CloudFormation template includes a task definition that deploys Jenkins for me on top of ECS automatically, and that gets deployed behind my load balancer, right? So if I head over to my EC2, my CloudFormation console, and I take a look at my Jenkins stack, I can see that in the outputs, the output has given me an application load balancer URL. So if I head over to the URL, you can see that I have, sorry. Apparently I don't have the login. All right. Sorry about that. Let me reload it here real quick. Maybe I can grab the login. I apologize. All right, it must have changed the password for me when after I deployed, so I apologize for that. So what I'm going to do here is I'm going to take a moment here to demonstrate what is actually happening from the console itself when it comes to what I've deployed. So let's take a look at the console and see here what is powering my Jenkins cluster. So my Jenkins cluster is first of all made up of a Spot Fleet, right? And so I can see which Spot Fleet is powering my Jenkins cluster by looking in my outputs. So I look here in my Spot Fleet name, C3E. All right, so this is my Spot Fleet request, right? And so we can see that it consists of a single instance. I've got a bid price in here right now. My bid price, of course, which I explained earlier, you only ever pay what the market price is asking you to pay. If I look at my overall cluster itself, you can see I have requested a target capacity of 1. I've allowed this cluster to utilize these different instance types within my cluster, and I've actually enabled the ability to scale this up and down based on the number of jobs in my Jenkins queue. And so what the Jenkins plugin does, had I properly set this up, the Jenkins plugin manipulates and changes the number of instances that are in my target capacity based on, again, on the number of jobs that it has, that it needs to get done. And so this plugin will interface directly with my Spot Fleet request and simply change desired capacity up and down. So if I did that here, if I said, please give me 3 Spot instances in my Spot Fleet would then get busy and start spinning up those instances for me. And so the Jenkins plugin simply does that for you behind the scenes. So a couple more things to show you here. This also deployed, I mentioned, an ECS cluster, so let me show you that quickly. So this is my ECS cluster, and you can see that this cluster is running on the Spot Fleet, and it currently has deployed one service, which is that Jenkins service running on one container instance. And so ECS, right, at the end of the day, doesn't care that it's running on Spot Fleet. All it cares about is that it has access to the underlying compute resources that it is going to deploy to. And then finally, I'll show you that this service then got associated with the load balancer. So this service has been deployed behind a load balancer. So this allows not only the worker nodes to scale up and down when it comes to my Jenkins cluster, but it also would allow the front-end Jenkins server to scale up and down if it needed to on top of ECS because it lives behind a load balancer. Okay, so I'm going to stop here so I can stop sharing my screen.